It will be very brief to tell a bit more about the group on complexity modeling. Before getting in what is the group, I think it's nice to talk a bit more on how we started. It was two conferences ago in Oslo, right? And I remember it was a methods session that Jonathan was leading this session. And I think Sabrina and I will approach Jonathan with the same idea. Maybe it would be nice to connect to like-minded people that are trying to do modeling. Do we have the resources available and so on? And Jonathan was very kind I mean, being kind and challenging, right, Jonathan? At the same time saying, well, it's a bit up to you guys. Maybe you should think of starting. And I think we took the challenge. We started meeting first the two of us. Okay, so how could we start something? Where would be the best place to connect this group? And we realized that in Nest would be the best place because we have people starting maybe getting into sustainability transitions, and we put it there. So since Oslo, which is 2 years ago, we have been meeting. Right? I think since then we learned some things. We are already more than 50 people signed up to the group that at least are receiving the emails and have been, connected with us in different meetings. And I think some of the main learnings that I had was, it was not only people doing their PhD, it was actually quite many people doing modeling a bit forward in their career and trying to get into transition studies. So this was one. We are very spread out, so we are in many different places. And also the interest of modeling was very diverse. So at the end, we chose the name of complexity modeling, and it should encompass system dynamics, ABM, network modeling, evolutionary modeling, AIMs, machine learning, and so on. So we are making this group to get the like-minded people that want to learn about modeling in transitions to get to know each other, maybe find ways to collaborate, find ways to learn, and also find ways to understand how we can contribute to understand better transitions. Not understanding, but enabling transitions. In a nutshell, I think that's it. One other key learning was, I think the first idea was that we would have way more people coming from transitions and wanting to understand how to model. But we also have many people that know about modeling, but they don't know too much about transition. So we can exchange quite a lot. And I think this group can become a stepping stone for people that are modeling already and would like to engage into very important issues. One of the first things, in addition to our meetings, is that we are creating right now what we call the Knowledge Hub, which is this other slide. And I think it's in the chat, or it will be soon in the chat. Yes. You can see a bit more or add entries. So if you go into the C, so if you explore the Knowledge Hub, this has been created based on the knowledge of people from the group. We made a few questions, which is you can find on the add entries, trying to understand who you are, where do you work, which type of complexity modeling are you interested on, and then we ask about what are the key resources. Both resources in terms of groups that we should connect, but also key literature coming from this modeling. So if you're coming from system dynamics, what are the key literatures there? But if you come from transitions, what are the key literatures that you need to understand to make sense of modeling? And you're going to see a first version of it. So based on the responses that we have just now, you probably see a document that it's right now, it's a page, it's like a Notion page, where you have information one by one from the modeling approaches, key communities, some basic literature to engage into modeling or start learning. and some transition-specific literature. So you have literature that are specific on system dynamics within system dynamics, agent-based modeling within agent-based modeling, and so on. At the end, on 4, you have about general modeling transition literature. So a lot of literature that are more overall, that maybe they try to combine different modeling, have a better overview on how do you address transitions through overall modeling. So you have this basic literature. It's an ongoing process, and you are more than welcome, and we actually ask you if you'd like to participate, go into add entries and add your contribution there. We, the group, right now represented by Sabrina, Anna, and I, we're gonna be updating this document, making it to a live document that hopefully becomes useful for those joining. Yeah, I think from my side, that's it. Finally, just the final point. By knowing that there would be this event led by Nest and led by Jonathan, we thought that it would be cool that we could make a sort of a joint event together. So thanks for accepting us to accept that we join forces, and we look forward for today.
Okay. Me next, I guess. When I get my screen control. Can you see that okay? Are we in full screen modus, presentation mode?
Yes, perfect. Thanks.
All right. Okay, okay. Well, for the reasons of time, we haven't introduced me in any detail. I will just say I'm Jonathan Köhler from the Fraunhofer Institute of Systems and Innovation Analysis in Karlsruhe, Southwest Germany. I'm also one of the originators, not the very originator, but one of the originators of an organized activity around modeling in the Sustainability Transitions Research Network. It was actually Eniat Moalemi and Fiala Khan who approached me originally, and because I published at least a discussion article or two about it, and I've met them in various meetings around transitions when it was starting up quite a long time ago now, in the early about 15 years ago. And a bit of background, very briefly, is that in those early meetings, I came to the transitions community from a background of climate policy integrated assessment modeling. And I got interested in what I would call long wave theory, of which transitions theory is a multi-level perspective, is a variant, through talking to Franz Berkhout at that time, because in terms of modeling climate, it was obvious to me that you have to model large scale, long period, major social and technological changes in economies and societies. And there was the models that were being used to do that, the integrated assessment models, I thought were not appropriate for the problem. And Frank Berthout introduced me to the work of Chris Freeman, who effectively developed the ideas which have now been interpreted into the multi-level perspective quite a long time before Johann Schott and Frank Hales and René Kemp started up in the late 90s. Having said all that, we set up a modeling group for the STRN, and we did a couple of papers, and this is the second one, actually. I certainly felt, I don't know about the others so much, but I certainly felt that this STRN didn't take modeling seriously. A lot of them thought that modeling wasn't really useful for doing something as complicated as studying transitions. And And therefore, I thought it was useful to form a group to promote the use of modeling in the transitions community. And the amount of papers that was published was very small. Then you just move down. Yeah, and when we started talking, there was only around 20% of papers that talked about quantitative methods at all. This might sound a statement of the obvious to you all, but I just want to explain the way I think of the problem around modeling transitions. We know they're complicated, wicked problems that then involve a lot of different aspects. The knowledge, capabilities, and employment of various actors relevant to existing systems, technical infrastructures, and institutions, as in ways of doing things, standards, etc., that have developed over time, the economies of scale and markets of incumbent systems, the social significance of these systems. In Germany, they're worried now about why is the German car industry falling apart because they can't sort themselves out and do batteries properly. And the German car industry employs indirectly and directly a couple of million people in Germany. So it's a big, big problem. The mutually reliant clusters of technologies, to continue that to that example, oil, steel, internal combustion engines, and the everyday practices and lifestyle values. Everybody drives a car, or almost everybody, etc. And these and so the idea of a transition of a socio-technological regime is what really kicked off the STRN as an academic community. But for me, again, if you look at the models that were around at the time, they more or less didn't address these questions at all in the way that was necessary. You either had very detailed models of particular aspects, behavioral models in transport, sure, and detailed models of demand, but at the larger scale of a regime transition, there was nothing remotely doing this sort of concept. You had basically long-run variants of computable general equilibrium or neoclassical models or Keynesian macroeconometric models, which were then just projected out a long time into the future and basically were extrapolations of previous data. And for me, this was completely inadequate and a completely inadequate approach to a structural change problem. So when we were thinking about, okay, how do you go about modeling transitions? What makes a transition model a particular sort of model? Rather than trying to look at particular theoretical approaches in modeling like complexity or environmental economics or ecological economics or complex systems analysis, etc., it rapidly became obvious to me and to the others that there is actually a very wide range of mathematical theoretical approaches out there. So it's not that you start saying, I think we've got the thought, we've got the methodology. How do you then apply it to transitions? Rather, we chose the opposite way around and said, okay, what are the features of a transition that we want to model? And this is what this slide addresses. So the way we express it in the paper is that a socio-technical transition profoundly alters the way a societal system functions, as well as the actors, practices, institutions, and technologies involved in production and consumption. A transition, then, is a change from one socio-technical configuration to another. So there is the two things. What you get out at the end is different in terms of its structure, whatever that means, to what went in. The dynamics typically start slowly due to multiple sources of inertia manifesting in the regime, and the changes are often long-term intergenerational. They are what we call polycentric processes, which actually means multiple actors, multiple factors of change, multiple temporal and spatial scales are relevant for shaping the dynamics. And we also identified two types of transitions, really. One which is triggered purposefully, which is what sustainability transitions are all about. And another sort, in particular, the historical examples, emerge from ongoing developments. And that's where the connection to long waves and contractive waves and general purpose technologies is. That in the past, you can also see, well, you can see very good examples of large-scale socio-technological change, all the Industrial Revolution, the digitalization, excuse me. And these are definitely, as far as I'm concerned, socio-technical transitions. They're not sustainability transitions, but they do lead you into thinking about what is the structure of the problem that's going on. The other thing is that transitions are complex in the sense of complexity science. They are open and path-dependent processes with very uncertain outcomes, whose dynamics are not only determined by the external developments and conditions, the landscape, but also emerge endogenously from interactions with the system. You can say, if you like, that they are co-evolutionary. So having said all that, what does that mean about what a model has got to do in order to be, for us to think of it as a transitions model? It's got to be capable of producing nonlinear behavior and path dependency. And that is already a very definite statement, let it put me that way. Optimization models won't do. You're in a world of simulation models, really. They have to be able to represent qualitatively different system states. And this is a very tricky thing, because a qualitatively different state means that it's got the end state has got different things in it to the beginning state. But if you're writing computer simulation, you've got to predefine your variables. So you've got to find a way in which your model is structured such that you can represent the transition in some way, while already identifying the indicators or the parameters that will tell you whether a transition is happening or not. You have to be able to represent diversity and heterogeneity, because the fundamental story of a transition is about a little niche growing and taking over from the regime. So something on the average completely misses what's going on, completely and utterly, because what's going on is in the niche. It's in a small corner of the data over there. So average data is no good. You've got to consider a distribution of behaviors or actors or technologies or whatever it is with a distribution of characteristics. And then you've got to be able to consider at least the different scales of what level a niche is acting on or working at, as opposed to a regime. So you need ability to represent dynamics across different scales. And you need to be able to incorporate uncertainties or contingencies, ideally. And of course, if you're into complexity theory, you know that the mathematical structure is also uncertain. So those are the considerations which we wrote down in the paper. And then we quickly reviewed some of the approaches to modeling that we thought, which we knew were being used to look at transitions and which we thought might be appropriate in the literature as it was then. This is 2016, but actually, in the sense of these overall approaches, I think the paper is still very, very relevant today. And I've got two slides here, and we tried to find a way of graphically representing a qualitative assessment of what the different modeling approaches might do. And here we had eco-innovation models. We talked about evolutionary models. We talked about network models. And then we looked at computational social system modeling, which is the literature, system dynamics, and socio-ecological models. And the CSS literature is also very much into agent-based modeling. And what we just did, we looked at the different aspects of what these different literatures, how well these different literatures covered the aspects that we thought were necessary for a transition model, and we got these results. So for the eco-innovation models, they were okay for nonlinear behavior and good for path dependency, but not so good for qualitatively different states or normative aspects. They were mostly at one single scale and weren't very diverse. The evolutionary models, I think, offer a more open-ended and overall fruitful opportunity. But I would just want to say at this point, while I start making my judgments, you should take my judgments with a large pinch of salt, and that fundamentally no modeling approach is inappropriate. You've got to find a model that addresses the phenomena that you want to model properly, that's such that you can represent the actual important characteristics. So we are in principle model neutral. It's just that optimization models don't often represent the characteristics that we need for a transition very, very well. But anyway, evolutionary models do have nonlinear behavior. They do have path dependency, and in particular, the idea of evolution amongst a set of actors is a very important one. And in the literature as it was then, they were medium good at different scales and medium good at qualitatively different states. With network models, they're also good for nonlinear behavior and therefore have path dependency if you use them in a dynamic mode rather than a single point in time. They weren't so good on the other aspects, although we thought, a reasonable job potentially on qualitatively different states. So network models and evolution models came out well here. And for the computational social science models, that is where they at least partly tried to have some modeling of agent-based behavior. But in particular, they were quite good at path dependency. They looked at different scales and diversity well. They were not necessarily so good at qualitatively different states, similar to the others. But one thing that they did have was normative aspects in them, such that you could look at how actors were behaving. System dynamics models are good for nonlinear behavior and path dependency. Not quite so good for diversity, because you find when you're programming system dynamics models, pure system dynamics models in the sense of Vensim or whatever, they aren't really attuned to representing lots of different actors. So a very explicit system dynamics approach is difficult in that respect of representing diversity. And the socio-ecological models, which is again a different literature, but often large scale, they're quite good all round. Their modeling tends to be less evolutionarily explorative, but they do cover different scales and diversity and behavioral normative aspects quite well as qualitatively different states. Having said all that about the different models that we considered and produced in the in the paper, I personally feel that agent-based models, which have become much more popular in our literature, are a very good way to go, because agent-based models are are simulations automatically, so you can create any sort of dynamics that you want, and they do emphasize this diversity element of the difference between a small niche and a regime, or how a market grows that's not been there before. So I personally have used agent-based modeling techniques. But like I say, you should choose the models that are best suited to what you think you want to research. The conclusions here, quite apart from what sort of models you might use, is that when we were looking at the literature, and I think this is for me still problematic, the models weren't really good at representing profound or qualitative changes in societal systems. And that is a criticism, because that's one of the things that you need to do. But it is also a very, very difficult thing to do. How do you define what is a different system compared to the system that went before? And it's these qualitative changes that what is a qualitative change in the system? What makes the next regime different to the previous regime? That's what you've got to work out and then find a way to represent. For me, the characteristics of transitions lead you to think in co-evolutionary terms. So the idea of systems or subsystems or agents co-evolving, influence each other, feeding back through time, but changing themselves, I think, is a very important one. There are lots and lots of opportunities around coupling ecosystems, the socio-technical systems, which is a very limited literature. There is the socio-economic, socio-ecological systems literature, but it's very small. And the actual modeling of sustainability is something that the STRN world hasn't emphasized so much, and that's one of the major criticisms of it. And then another critical point is this linking between the micro and the macro scale. And how do you represent a landscape or a macro scale as opposed to a niche or a micro scale, excuse me. And then the usual one comes at the end. How do you deal with the empirical aspects of transitions, calibrating a model? And this, again, is a very reasonable but a very tricky question, because you are modeling into the future, where the future is systematically different to the past. So the data that you have from the past that you would use to calibrate a model under normal circumstances, let me put it that way, is only partly valid. It can tell you where your starting point is, and it can tell you about the trends that are currently there. But in terms of a qualitative system change, the historical data is not necessarily going to tell you very much about that. So for me, transitions modeling is about, yes, defining an empirical case, yes, finding empirical data, but then you have to have a theoretically grounded way of saying what's going to happen in the future. This is true of all sorts of long-range modeling, but it's particularly true in these transitions with very profound non-linear impacts. So that's all I wanted to say. The paper's quite old, but like I said, I still think it's very relevant today. I think it's great that so many people are here today, and that you're all at least thinking about taking up this challenge of modeling in transitions, which is much more difficult than just going and doing a sustainability model and the next generation of, for the sake of argument, climate models where you're worried about how you get your cubes smaller to model the physical and chemical processes more accurately. Here, we are really have the challenge of a difficult modeling problem, and we've also got the opportunity that it is not really an established literature, so that there is no one generally accepted way of modeling, and I think that is a good thing. I think it allows you to be very open in your thinking, which is also necessary if you're going, in my opinion, to write good transition models. Thanks very much for listening. And we'll have a very brief question and answer session now and then go into a group discussion next. Okay.